Go down a little more.
Oh, hey. Peace. And far out. How to remove carbon from your piston. So I've heard all kinds of stories on that. Anyway, I wanted to do a little bit of piston talk that we have here, and because I didn't print this out and I'm headed outside to get some firewood here shortly, I figured I'd start. I'll continue this a little later on another video, but yeah, sorry about the glasses and the light, but that's the way it is. One of the things I want to show you here is this is a typical piston in a car where the oil has not been changed. And you notice up top it's black, but it's not heavy deposits. And up here at the top it's shined, but it's not shiny all the way around. I'd love to see the other side of this piston, but they don't show it. Well, anyway, down here, this is dirt in the oil every time, and you notice it lessens as it goes up through it. But the ring lands are clean, which means not much came down. So most likely this is a car that was running, well, not a car, it looks more like a tractor, but still it could be either one that was running rich. Just plain running somewhat rich, and that usually puts fluffy black deposits on there, but if you get it working hard enough, you'll clean them up. Now, if this was an air filter that went bad, what you see on the bottom here, you would see more up here around the ring lands, and it would get less as it went down. And in some cases, it does get worse as it goes down because it carries so far. But that's quite often how dirt gets into the oil, is from dirty air that goes by the rings and just wears them out. There is somewhat of a picture on here that I can, well, where'd it go? There it is. I've got my nice little sweet Olight piston. Now, like I said, I'm doing this because I didn't. Now, if you can find a picture here, you see that little black line there? That's actually where the second ring was starting to dance up and down from where the oil getting past the oil ring. When it starts to dance, it rolls the edge of the ring land where your ring is in here, and it'll beat the thing, roll it right up and over because the ring is starting to twist because it's wearing. It wears to the outside edge first. Well, now the ring starts doing this and beating on the ring land. That's one of the ways you get cracked ring lands later, but usually they just wear out. What else can I notice about this piston? Well, pretty much I could keep going, but in the picture, that's about it. There is no, normally what you will see on a piston is, like this one, you see that it's scuffed all the way. Now this is actual scuffing. And you notice it's scuffed all the way across, all the way out to here, and then it stops. Well, the piston's cam ground. The aluminum is thick through here for the wrist pin, right up in underneath the head as well. So they cam grind them. This is actually narrow. That's why you do all your measurements back here. Now, depending on your Kohler, well, engines will tell you to measure from here to the piston wall, or the cylinder bore, and others will tell you to measure from here. Well, why would Kohler do it up here? Well, because it'll be narrower here, and the piston has a slight taper to it. Why? Well, the same thing. The aluminum's thicker up here. This is a guide to help keep the tab is a guide to keep the piston from rocking as much. A high hour type of piston. The holes obviously are to scrape the oil back, and that's one of the reasons that the oil ring has been working relatively well, and that's why all the dirt damage is down here and below. Bad breather can do that. Bad PCV valve that has constant vacuum on it will draw in more dirt. A lot of stuff that can cause that problem there on pistons. Now, the top being black like that, like I said, is usually an over-rich mixture. Most pistons in a gas engine you'll see are clean. Now, on a diesel, they will look like this. Burning as a diesel, black. If you're over-fueling, it'll be fluffy black, similar to a gas engine. But they're quite fluffy black deposits anyway in a proper burning diesel, but the later high-temperature diesels, your compression ratio is up in 17 and 18, 19, and in some cases 25 to 1 or better. It may sound crazy, but some of the little Kubotas turn in high RPM, run the higher compression ratios, naturally aspirated. And that gets the high heat that causes the NOx emissions. And that's why they give you the EGR valve. You need the pressure to make it fire and build you the power, but they want the heat to be reduced in the combustion, and that's why they pollute the incoming air with exhaust. It takes that sharp temperature out, and they're trying to take out enough temperature that takes the nitrogen from the air and mixes it with oxygen in the combustion process and sends it out as nitrous oxide, NO2. So they'll all call it nitrous oxide anyway, NO, NO2, NO3. But they'll tell you they're just trying to get rid of all NOx. All of it. Okay, it's great. So anyway, that's what the EGR is for. And it works. It does its job, but you're polluting the engine. So you can get pistons that look like this if you don't have good clean fuel filters, good motor oil, engine oil changes consistently with good filter. Yeah, you hear what I'm getting at? In other words, your maintenance procedures need to be up constantly. With the higher compression ratios, one of the things that happened is, remember I talked about that ring gland rocking. Well, there's higher compression. The top ring is doing harder work, and that means the second ring has to back it up. And there's going to be pressure between the two. So that's why sometimes you'll hear some of these guys with less ring end gap in the top, which is counterintuitive to try and keep the compression in, and then the one below has a little wider, just to deflate it so there's not too much pressure behind the top ring, because then the ring sits there in the gland with compression pressure on both sides, and it'll float and vibrate. Well, when it does, it starts banging away at the piston when the pressures change and oscillate, but at the same time it's called ring flutter. You'll get a lot of blow-by. So that's one of the reasons that assembling the engine is very important, but even more important is your work, your maintenance with that unit to be sure it's in good condition. Yeah, those are the main ones. You would say, a lot of people would say, well, it doesn't matter. You got your high pressure diesel injection system. It has to be clean to operate. Well, it does. But if it doesn't operate properly and you don't have clean fuel going through it, then it starts to screw the things up. The valves, the pressures, the sensors, and all of that, even coming out to the injector, which in the new style injectors, the Bosch style system of an unbalanced, not the Huey system, but an actual injector, still has a poppet nozzle on the bottom from the 1930s. You don't think about that, do you? Because the injector comes out this tall. It does. Solenoid valving. And then finally at the bottom, because they have to have a body in there to handle that pressure, 30-some thousand, 40,000 pounds of stored injection pressure in the common rail system in some cases. Well, we'll go with 25 to 30,000 as a common. It'll build up and store it, and they got to have the body to handle that pressure. Well, down in the bottom is a poppet nozzle of your injector. How in the world? Well, there's orifices in there to fine-tune everything, but what it adds up to is the poppet nozzle is held closed by the injection pressure of the common rail. It's in the back side, and it's on the front side where it normally would pop the valve open. Well, why doesn't it? Well, the pressure against that is important. So that is calibrated as well, plus your computer pressure, plus anyway with your orifice. The idea is at the top is that little solenoid that controls what they call a two-way valve. Well, they call it two-way, big deal. It's open-closed, it's on-off. It's like a single pole, single throw switch. Click, click, that's it. So, yeah, it is. It gets its little flutter, whoop, and a little bitty teeny pintle down there unbalances the injection pressure in the tip. So now it pops open just like a regular poppet injector. So, well, it's got to close. It does. Bloop, bloop. As soon as it closes, all that pressure is still flowing there, shoves that valve shut. Because you have pressure above, pressure below, and the spring closing the thing. That's why the spring has to be calibrated. And that's also why you will have those great big long numbers on there called an offset or a calibration number. It tells the computer how to handle the electricity going to it and the pulses to open that thing. How fast, how quick, how short, how whatever, just so that valve pops. and ends up spraying all the injectors in an identical manner, but maybe this orifice is off, the spring is off, maybe everything is not perfect, but this injector will function properly under certain circumstances, and the computer controls them. You probably didn't know, but your power shift transmission has usually its own controller as well, computer, telling the little solenoids that are now EPC solenoids, just like this two-way valve on the injector. Only these are even more precise, and the controller tells it when to open, how fast to open, how far to open, how fast to close as well. You didn't know that, did you? Yeah. It's important. So that's how they don't have modulation valves anymore. They have modulation programs. So anyway, that's something that I figured I'd get into with diesel, that when you have a problem with your injectors. Now, here's an interesting one to think about. I forgot all about, because we're still talking about black on top of the piston. How does a diesel overfuel and everything's normal? You check it, everything's normal. Well, how did it? Well, quite often what's missed is the last one, and Cummins did a poor job on this. Their style of testing still works, but it's not kosher, so to speak. However, it does something else, and I'll explain that as I go along. In your common rail system, one of the reasons you'll get overfueling easier than normal, you notice, oh, my machine's overfueling as it gets older. Man, that sucker's got some power. And you don't realize that actually is a problem. But it sure doesn't feel like it. These things in the 300 horsepower engine can gain 20 to 50 horsepower and then start causing trouble and throwing codes. You're like, but it's running great. Yeah, it is, and you're going to be disappointed. What happens? The two-way valve wears, the orifice wears, and the valve wears down below. And what happens is, as soon as because everything's slick now, if you've had clean fuel and it's working right, the two-way valve just starts to crack, pop, the pop it goes. So it's injecting a little earlier. And then because everything is flowing by, yeah, the two-way valve closed. Took it longer to close maybe, but more than that, it takes longer because the fuel is going past the nozzle tip, the plunger, and it doesn't close as fast. So you got a broader injection, and the computer's saying, wait a minute, I'm throwing the same stuff at it here. Well, then the computer's taking a look, and the common rail is running out of fuel quicker. So what's it do? It goes back to the pump and says, more fuel. Well, what happens is it comes to a limit that's been set in there, that the pump is probably, not always, but probably capable of handling without a problem. But it's beyond the threshold that's set in there to say, yeah, we got to back this off because the engine's going to start overfueling and overheating and cracking pistons. Especially if you're running a long-term, long-life engine that's designed to run, in Dozer's case, at least 10,000 hours. At least. When you're running a Komatsu and some of the cats, 10,000. Don't even bat an eye. Isuzu's engines and some of the Hitachis and such, you know they're going to go 10,000 hours. Maybe not much beyond that, but you know that Isuzu is going to go 10,000 for sure. And if you take care of it, 15 or 20, just like the cat or the Komatsu. But you have to be more precise than some of the cats and most of the Komatsus. And all this after treatment has taken engine life down considerable. What used to be in a loader and a dozer, a 20,000 hour engine for a cat or a Komatsu came down to 15, and the life of the engine keeps coming down. But our oil change intervals go further out. Well, yeah, it's because the problem with the oil is they can't put the same stuff in they used to try and keep the engine alive longer with the higher heat, higher pressures, and the fuel with less stuff in it. There's less sulfur, there's less ash. The fuel's going to be better for the fuel system. Not necessarily for the rest of the dozer. And for the after treatment, because it can kill the SCRs and the catalytic converters in the DPFs. What a lot of people don't know with all of this is that while it's overfueling and you don't even know. It goes through a catalytic converter, and that wipes out some of the NOx and even some of the carbon and the hydrocarbons. It goes through that and hits the DPF. DPF blocks 90% of all your smoke and fog 90 to 95, so you don't even see anything. And that's when it goes through its regen, which is bizarre to me because to go through a proper regen half the time, they have to put fuel in it to hit the catalytic converter back here to get the stream hot enough to cook the soot out of the DPF. Well, there's still some NOx getting through that, and they're all concerned about that NOx emission. Well, it can cause acid rain. There's a lot of it. That's what happened in the 80s and 90s with acid rain in the cars. There was after treatment to get rid of NOx and some other stuff, but what came out that they didn't think of is not every car is going to run perfectly. So it ended up putting out more sulfur dioxide into the air, causing acid rain, or nitrogen dioxide mixing in the air. Yeah, it didn't work. But we still have them. Some cars with cars and trucks with 6 and 8 of them on there. So anyway, once it gets through with your DPF, now you still have a stream that may have too much NOx emissions in it. What do they do with that? You come downstream and there's an injector. Now it's a similar injector to what when they said they put fuel in the system back here to help burn the DPF out. Well, I'm not even talking flamethrower systems. I'm talking just throwing diesel fuel in there that hits that stream and it's right there ready to combust, but not quite. And then it hits that catalytic converter and comes alive, but there's not enough oxygen in there to make a flame. But it's hot. Thousands of degrees hot in the center of the stream. And they may have an injector here instead of using an injector in the engine to spray during the beginning of the exhaust stroke or halfway through the exhaust stroke. They may actually put an injector in there to blow the diesel in, go through all of this, and yeah, extra fuel in the stream to cook the burned fuel particulates in the DPF. I know, it doesn't make sense even to that point, but we're not done yet. Let's just say this part works. Don't look at the consequences on manufacturing and disposal, just say it works. Now we come downstream and we've got too much NOx. They have a similar injector spraying horse urine into the stream, 32.5% urea. Thank you very much. Goes into the heat of the exhaust stream, which if the DPF is being cooked, is really hot. Goes into a catalytic converter because this is mixed and sprayed in with the exhaust. Hits the catalytic converter and is supposed to take care of enough NOx emissions to meet standards. Not all of it. But after that, what happens? Well, to convert it, it turned it to ammonia. Well, now they have to have another catalytic converter that's an ammonia trap. They have a fancier name for it, but that's what it is. It's an ammonia trap. So in between the two is where all the activity is done, where it starts the catalyst process here and finishes it, and then the ammonia left over, it traps it here with the other one. And there's sensors in there. NOx coming in, NOx coming out, ammonia coming out. And any one of the after treatment sensors will shut the unit down into a limp mode, and the engine could be running perfect. Nothing wrong at all with the engine, but the after treatment will shut it down. This is bizarre, but that's the way it is. Now, you purists out there are going to be saying, well, what about, yes, I'm getting there. A lot of the newer systems, especially the Europe's over there, have been playing around, I mean in Europe, and the EU and all that. Went to a system early on, and I think they may or may not have gotten out of it, but what they were trying to do was simplify the whole system. And what they did was put a bigger catalytic converter in there to do a lot of the soot conversion, what's left over. They tried to take care of the soot in the combustion chamber, get enough air, heat, and everything, and just let the engine go nuts so it can put out more power and burn better and more efficiently in the engine. And when it comes out, there's less soot, so it goes through the catalytic converter, a little bigger, takes care of more soot, more NOx emissions coming out of here, and even hydrocarbons, obviously. It goes through that, and there's no more DPF. It's gone. Because the SCR system, supplemental catalyst reduction, is taking care of most of the rest of everything else, so it's coming out the end in pretty good shape. Now, some of the early systems they had overseas was a constant, just like this system I'm describing, even may or may not have had a DPF in there, but they'll have a constant spray of urea, 32% urea mix coming in there. Constant. Without the catch converter. And without the sensors here either. Stink. What it had was an algorithm that would see how much NOx was in the stream and just puke in urea to take care of that. And whatever happened after that, whatever. 5,000 hours later, everything's wore out. Nobody cares. Now you're sniffing ammonia. They used to fog up the shop until your eyes would water. 3, 4, 5 tractors down here at Monroe Tractor. Just nasty. And the funny part was, similar tractors working for Empire Tractor, New Holland series, didn't have the problem. But they don't have the bigger tractors that head down here at Monroe. 190s, 240s. What was the other one? The 290. Some bigger tractors down here, and I don't know why, because Empire is up there in farm country. We're down here below farm country and above farm country. It's like city dweller there, but still they had the bigger tractors. So we ran into the problem more often there. Anyway, that's one of the reasons you could get overfueling in a diesel. All this crap is here. They turn the engine up to do what it wants to do. They have the after treatment to allow it to do it. Then you could get some fluffy pistons in there. If any one of that part of that system goes bad, you can get overfueling, and the engine's doing nothing wrong at all. So that's makes for an interesting time when you're studying the pistons. What was the problem? Well, you may come up with a problem further down through the fuel system in your after treatment. Why? The after treatment plugs up and has too much back pressure. Now you have some other problems that can back up the fuel system. Engine's still trying to put the power out. The sensors are doing funky stuff on down the line for the after treatment to take care of it. So you can end up with everything's fine except you got a restriction. Your DPF maybe it should have been replaced, or something went wrong with an injector and plugged the thing, and now you've got regens going on left and right. You're like, well, what's causing it? Well, it could be just plain. Most often it's two simple problems that have nothing to do with the engine itself, technically. The computer quite often miscalculates and just says, whoa, we better do something here because I don't like it. It's too cold, or it's too hot, or it's too this or too that, and it's going to make more soot than normal. That's one. The other one is the jackass in the seat keeps pushing the inhibit button. I don't want it to start a fire in here. Well, if you have to push the inhibit button twice, park the tractor and put it through a regen. And if it won't go, call your dealer, because you're going to screw everything up and it'll cost you 10 grand. You just push the button once too many times, and now it just costs you 10 grand because you plugged that cat. And the DPF part of the catalytic converter section after treatment. And that screws up the combustion all the way back in because of back pressure. Changes the algorithms, changes all of it. It's a mess, I know. Overall, it would have been best if they'd have left things alone. But they can't. So now they've got to the point where they think they have enough combustion swirl, the fuel, and they're talking combustion swirl itself to mix the air and the fuel enough to burn a majority of it before it even comes out, which means they might be able to even they couldn't do away with EGR, but they can do away with everything else if we were back 15 years ago. No after treatment needed, even 10 years ago. So there's a lot of stuff here that you may be reading in the engine that might actually be nothing wrong with the engine. Could be out here in your after treatment systems. Your standard diesels from the past, you might even see mucky stuff, gooey on top because of a bad injector. Black stuff on top from a bad injector as well, causing overfueling because the pinwheel's stuck open. Usually that's raw fuel, but sometimes it's just it won't close quite right and it'll pee a little bit out and just plain cause overfueling. Preheaters. There's some preheaters that actually have a thermal valve. And you turn to preheat and it starts heating up this little glow plug, and the glow plug gets warm enough, fuel comes out and catches fire, and now you crank the engine over and the fire goes in the engine to start it. Literally. So that goes bad, fuel just pukes in there. So read your pistons, you'll learn quite a bit. Time for me to go. You be good.